Hi, hello dear students. Welcome to my class on ionization enthalpy. This is the continuation lecture of the periodic properties which was discussed in the previous lecture of periodic table. In this lecture, I would like to discuss about ionization enthalpy and rest of the periodic properties. So first of all, ionization enthalpy is what? What is ionization enthalpy? It is amount of energy required to remove an electron from isolated gaseous atom to convert it into monopositive ion. So if you observe this equation in this, what is M means? M is the neutral gaseous atom, and M plus is monopositive. So we removed electron and some enthalpy is noticed. This is called IE1. We can call this enthalpy is ionization enthalpy. In kilojoules per mole we will express this one. Whenever this process we are doing, this is energy required, means energy which is absorbed by the neutral gaseous atom to convert into monopositive. That's why it is always endothermic and thermodynamic process. The ionization enthalpy now has become positive. If you continue doing the same, second ionization enthalpy will definitely become difficult compared to first ionization enthalpy, because when you remove the electron from positive ion, that is definitely difficult because of the nuclear charge. That's why the first ionization enthalpy is lesser than the second ionization enthalpy. This is a very common question in the examination they are going to ask. Next, generally if you continue doing this type of process by removing electrons one by one, always this will become difficult. So it is more and more ionization enthalpy value is getting increased on successive ionization enthalpies. That's why you just take it, this one IE1 like this, and IE2 will be like this, that is IE2. So IE2 is going to obtain when you remove the electron from monopositive ion, whereas IE3 if you take, IE3 will be calculated by considering dipositive ion and removing electron from dipositive cation. You will get this electron M3 plus tripositive. So in this we have three ionization enthalpies we have shown: IE1, IE2, IE3. So in these three, how this order is there means we told successive ionization enthalpies are increasing. So IE1 is less than IE2 is less than IE3 is the correct order of the ionization enthalpies. Next, if you move to the other point here, what are the actual reasons, what are the factors which are now the reason behind the different ionization enthalpy values? That first you can observe one thing, that is called atomic size. Second, nuclear charge. Third one, screening effect. The fourth one we'll call it as penetrating power of electron, and fifth one, electronic configuration. Means if any one of this property they discussed in the exam, that is changing the ionization enthalpy, we have to understand. And in that, atomic size if you take, ionization enthalpy decreasing with increase in the atomic size. What do you mean by this one is, it is inversely proportional to atomic ionization enthalpy. So ionization energy is inversely proportional to atomic radius. Whereas second one, if you observe nuclear charge, if this nuclear charge is increasing, ionization energy value also increases. So increases. So what you understand here is direct proportionality. Ionization energy is directly proportional to nuclear charge. Third one, screening effect. So if the screening effect is nothing but something, the nuclear charge, nuclear force will be coming different for inner electrons and outer electrons. So inner electrons are keeping the outer electrons away from the nuclear charges. That's why ionization energy decreases when it increases. It's inversely proportional with ionization energy. So screening effect and ionization energy are inversely proportional to each other. Whereas if you observe this penetrating power, the penetrating power nodes in this you observe this the same way, whatever the main energy levels if you take, s electrons are rushing towards nucleus more fast, then p electrons, then d, then f, like this is there. Means penetrating power, whatever you observed, penetrating power, that power is more means ionization energy is definitely more only. So that means penetrating power is directly proportional to ionization energy. And fifth one, electronic configuration. So what do you mean by electronic configuration? Means in this stable electronic configurations there are two types. One is half filled and fully filled. If any of the atom is having that type of thing, that will call it as symmetry, and exchange energies are more. Because of that, ionization energy will definitely increases. So that means ionization energy of the atoms having this half filled and fully filled electron configuration will be higher than the expected values. And how the variation is there now, if you observe, ionization energy decreases across a period due to increase in nuclear charge, whereas it decreases down the group due to higher screening effect. So ionization energy increases in a period and decreases in a group from top to bottom. If you see this graphical representations, in this previous one, you need to do one thing, that ionization energy generally increases in a period as nuclear charge increases, decrease down the group due to higher screening effect. Okay. Next, in this graphical representation of a first A group element, this for second period elements, lithium to beryllium increases, beryllium to boron decreases, boron to nitrogen increased, and nitrogen to oxygen decreased, oxygen to neon increased. So boron and beryllium, there is a question definitely will come, and nitrogen, oxygen also there is a question definitely will come in the variation of ionization enthalpies. This is because of the stable electronic configuration of beryllium, completely filled 2s orbital, and half filled 2p orbital of nitrogen. Because of these two reasons, you can say the variation is came like this. Another one, along y-axis we have ionization enthalpy delta H, and x-axis we have atomic number is there. This is for first A group elements, lithium, sodium, potassium came like this, and rubidium. And this is decreasing because size is increasing for this first A group elements, or any group element size increases means ionization energy decreases. Next, if you observe electron gain enthalpy, yes, that will be seen in the next session. So we will check with the ionization enthalpies in the next session. Okay, thank you very much.